Hi, my name is Scott Curry. In this presentation, we're going to learn how to use BIML and MIST to deliver dynamic, metadata-driven business intelligence, data warehousing, and advanced analytics solutions. We'll spend just a few minutes on slides to introduce some key concepts before taking a deep dive into the MIST and BIML products themselves. But first, let's talk about what this is really all about in the first place. We want to learn how to develop Microsoft BI projects faster, more consistently, and more reliably than we ever previously thought possible. And perhaps more importantly, to have fun doing it. After all, none of us got involved in business intelligence and data warehousing because we love the rote mechanics of building data infrastructure over and over again. We got involved because we loved creating new insights from data that nobody had ever previously realized. And now, with MIST and BIML, we can get back to having those great insights built quickly and efficiently while not having to sacrifice the key plumbing and auditability and other framework features that our enterprises require. How do we do this? Essentially, what we've done is taken the Microsoft BI and data warehousing stack end-to-end, the relational, the ETL or the ELT, essentially the data transformation framework in SSIS, and the multidimensional and analysis services, and we've modeled it as an HTML-like XML-based language that we call BIML. Now, in addition to BIML, we provide the ability to script BIML by introducing code nuggets, and we'll talk a little bit more about this in just a moment. By using both shared scripts that we can share across our projects or across our customer engagements, in addition to customer or project-specific scripts, we can hand those to a BIML compiler that will then automatically generate all of the assets that we need for an end-to-end BI or data warehousing solution. And in fact, all of these artifacts that get generated look exactly as if you had built them by hand. We generate DTSX packages that you can open up in BIDS or SSDT, and they appear to be hand-built. Everything that you deploy to the server requires no runtime whatsoever. This is entirely a design and development time solution, so if you're deploying to an IT environment that you don't have full control over, there's nothing to worry about. As long as there's a SQL Server deployment on your server, you can deploy assets that have been generated by BIML. The role of MIST is to serve as an integrated development environment for BIML to get the most productivity out of your development experience when using these advanced business intelligence and data warehousing tools. And finally, Vivid, which we won't be covering in detail today, is an add-in for Excel that enhances the business analyst experience when using Excel pivot tables in order to access data in cubes or tabular models. Given this high-level picture, let's drill down a little bit into what BIML actually is. So as I mentioned before, BIML is like HTML, except for Microsoft SQL Server. HTML has elements that describe document or pieces of documents, whereas BIML has elements that describe pieces of a Microsoft SQL Server solution. It's XML-based, so you can use any editor that you like that supports XML, and it's an open specification that supports third-party usage. So if others want to build tools that generate BIML, they're free to do so. In fact, we've started seeing that happen in the ecosystem. The real power from BIML comes from the fact that we actually have full fidelity with the Microsoft SQL Server product family. We have this saying, if you can do it in BIDS, you can do it in BIML. There are a few exceptions to this, but for the most part, it's true. So if you need to do some very specific details in an integration services package, for example, and you need to set expressions on a particular system-defined variable, or you need to add log providers or log events, or use custom components or script tasks or script components, all of those things are fully supported by the BIML language. And in addition to having the full fidelity support, we also introduce some abstractions that let you get work done faster through common patterns. Furthermore, everything is unified. It's not a different language for SSIS and a different language for SSIS and a different language for relational. We actually tie all of those together, and references can be made from one piece of the stack to the other. So if you want to change something about your data model, you can normally change it in one location and have those changes cascade through your entire system, rather than having to make those changes in multiple locations. All of this conspires to make BIML work really well with application development workflows. Source control finally works again because BIML is human readable and writable, unlike some of the formats that you've probably become used to dealing with, like DTSX. Automated build and continuous integration support now become easy. Building unit and integration testing frameworks are now very well supported by the BIML by the BIML solution to data development. And of course, you can apply this through any SDLC methodology that you like, including Agile and Waterfall. We have some customers that are actually using BIML to do week-long sprints on their business intelligence solutions, and that's something that becomes possible now with these tools. Now, as I mentioned earlier, once you have BIML, you'd like to be able to script it. So just like HTML has ASP.NET for scripting, where you can put code nuggets in to automatically create more HTML, BIML has BIML script. So you can take these nuggets of C# or VB code, and you can intersperse them within the BIML tags in order to automate the creation of new assets. So the key to this really comes in accessing metadata. So you can get metadata from your database schemas, you can get it from database tables, you can get it from Excel files, Access files, flat files, web services, basically anywhere that you can think of to get data. You get metadata about your project, you can get that and then use it to guide the generation of your assets. And if you're using Mist, you have a full live update experience and get to see exactly what will be built when you hit the build button. BIML script can operate in a variety of different modes. What we'll see today is going to primarily focus on live BIML scripts and transformer BIML scripts, which not only give you the power to generate huge amounts of assets from scratch, but also to modify existing assets. For example, being able to inject the logging framework into an existing package. And we'll see how that works in just a moment. The final slide we want to show is about Mist. Mist is the best experience for building Microsoft BI projects, specifically with BIML. It has a huge number of capabilities that not only match what's available in BIDS and SSDT, but also go well beyond it in terms of enabling really great team development experience, multi-monitor support, offline editing, and it has a tiny deployment footprint. The installer is only about 10 megabytes and takes only about a minute to install. Mist also has extensive scripting, automation, and framework capabilities that we'll see in just a moment. So with that, let's go ahead and jump right in and take a look at Mist. This is the Mist UI when it first opens. As you'll see, it has a modern interface that provides us both easy access to the projects that we've already worked with on the left and the ability to quickly create new projects on the right. In fact, these templates are very customizable, so in your organization, if you've created a project template with the frameworks that you're using for your organization or for your clients, you can actually add those very easily to this new project list so that your developers know exactly how to get started and get to hit the ground running. In our case, we're going to open a project that we've already created called simplestaging.mist. So when I click on that, it opens, and we'll see the core editing experience, the UI for Mist that we provide. And it's a combination of ribbons, as you'll see across the top here. And these ribbons conform to the standard ribbon definition, so they have all of the collapsing and other features that you would expect from a fully implemented ribbon. And in addition to that, we have tool windows that are used to have most of the detailed information that we'll need to look at. Two tool windows in particular are used for our primary project navigation. The first one is called Logical View. This one shows all of the logical objects that we've created across our business intelligence or data warehousing solution. Everything from our connections, which can be shared across all of our packages and cubes and tables and other assets. It includes databases, schemas, tables, dimensions and fact modeling if we happen to be doing cubes, packages, package projects if we're using Integration Services 2012, reusable file formats, script projects, which can be script component or task projects, which are reusable throughout Integration Services. We have cube definitions. We can do principal management. All of this is the logical view that we have, and if I double-click on any of these, I get nice visual editors, and we'll see those in just a moment. In addition to this asset-based view of the world, I can also look at the project view, which is more of a file-based view. And this is more similar to the Solution Explorer that you might be familiar with from BIDS or SSDT development that you might be doing today. You'll notice that we do have full source control integration, so I can, from anywhere in here, check in changes if I want. I can lock or unlock individual files. I can revert. I can update. I can do basically anything that I would normally expect to do in a source-controlled system. And this integrates presently with both Subversion and Team Foundation Server. We have a plugin model so we can easily support additional source control providers if required. So when I look at these files, I can double-click on any of these, for example, move data, and I get to see the BIML file associated with it. Now, if you haven't seen BIML before, this might seem slightly strange in terms of expressing a package or some other BI assets, but if you take a close look at the tags, it should be reasonably clear what's going on. If you're already familiar with SSIS, you know what a package is, and a package can have a name, and a package specifies a collection of tasks. Here we have an execute SQL task. We also have a data flow task. Inside that data flow task here is an OLEDB source. And then I also have a precedence constraint that is created between this data flow and this execute SQL, specifically saying that the execute SQL has to finish before the data flow can start. So all of this is the BIML code that corresponds to this package that I'd like to create. Now, if I switch to the designer view, which I can get to either by clicking on this other tab at the top or by just double-clicking on the move data logical asset that corresponds here, we'll see that I also get a nice visualization of my package. And if I put the BIML and the visualization side by side, we can now see one of the great powers of MIST as a design tool and as a learning tool for developing new BIML projects. So if I take data flow task, for example, and drag and drop it onto my design surface, we'll see that the code for data flow task is actually written. And if I create a precedence constraint, I get the code for the precedence constraint. And that goes in both directions. So not only can I edit my design surface and see the code get written, but I can also edit the code and see my design surface change. So I can change, for example, data flow task 3 to data flow task test, and we'll see that it updates there. And we're not limited just to making simple changes like name changes. I can actually put in another data flow, which will also now be connected to the move data flow from earlier. And I'll probably want to rename this to data flow test 2. And now with a simple auto layout, I can see that I have each of my data flows that I just created through a combination of code editing and visual designer editing. So this is something that's a very powerful approach. I have the option of doing things that are faster to do in the visual designer on the design surface, and I have the option to do the things that are faster in code in the code editor. And of course I can switch back and forth as I please, or if I would like to be doing coding but I'm not yet sure of what the right syntax is, I can make my edits in the visual designer and see, essentially have it teach me what the right code changes are to make. One of the other things that you'll notice is that across MIST we have very few dialog boxes, which is a refreshing change if you're used to working with BIDS or SSDT. By double-clicking or clicking on any one of the assets that I have here, the package details will show me everything I need to know about whatever I currently have in focus. So in this case, I'm looking at the retrieve data OLEDB source component, and here's all the configuration information for it. If I instead click on this data flow task 3, test 2, I'll see that I have all the configuration information for that task. If I want to, I can even undock this and put it on a second display, and it will continue to work exactly as it did when it was docked. So this gives me the ability to have a true multi-monitor experience where I can tile not only my package details information, but also things like my variables and my expressions and my annotations and my event handlers. So I can get a full view of whatever I happen to be looking at without any of my important information being hidden behind layers and layers of dialog boxes. You'll notice that we also have visual designers for all the other key assets. So if I open up a new table, for example, we'll find that I have both the BIML here and the design surface for tables, and I can go ahead and add columns. If I want to create keys, I can drag a column into the key area and it creates a new key for me. I can do the same with indexes. And if I want to do multidimensional modeling, we have the same sorts of approaches. In fact, I'm going to go ahead and get rid of the BIML here so we can see the full design surface. And here I can see I've modeled my columns out and done my relational modeling, and I've effectively done my multidimensional modeling in the same place. So here we have all of our attributes, we have our hierarchies, our relationships, and we have a variety of accelerators that will speed up the the creation of these things. So I can click on a simple button here to generate my attributes and relationships, or just one and the other, that will do essentially what the bids wizard does on the first run when I'm creating a new cube. And I can click on this at any time and it will update it to include any new information that may have been added to the relational model. We can do the same thing with fact tables. So if I go into a fact table, I get a full model of what the relational looks like, and then I also get to see all of my measures, and I have accelerators to speed this up as well. So for example, I could add in a new column, and I'll do a couple new columns, and then I can hit generate measures, and we'll see that it doesn't affect anything that I've already done, but it adds in the new measures that I just created columns for. And I can click things like apply measure formats and have it automatically apply measure formats for me according to a rule that, by the way, I have the full ability to overwrite that rule with my own logic if I choose. So we have a lot of nice accelerators in here that give you a great experience around the visual design to do things very quickly, but at the same time, you can always switch back to that BIML code and see exactly what it looks like. Let me do a format here so we can see it nice and cleanly. So here's the BIML code. So you might be wondering, well, if all you're really doing here is creating BIML code for things that you're doing visual designers for anyway, what's the point of having the BIML code in the first place? Well, there are a variety of advantages to BIML. One of them is that we handle modeling and referencing a lot of our objects in a much cleaner way. So for example, I can create a C# script task project. I can go in here and edit it, and I have a full IntelliSense experience. And unlike SSIS, I don't have to create a new script task project every time I want to instantiate this. I can create this once and then go into move data and search for script, put a script task on here, and then all I actually have to do is reference that script task project. And I could add 15 more script tasks and just reference the script project from each of those tasks. And then if I update the script project centrally and do a rebuild, I get that in all 15 locations. So there are some things that BIML's a win for just because we've modeled things in a more convenient way for code reuse. And of course, then the copy and paste that you were seeing can be a much faster way to get work done. But the real power of BIML comes in when we start talking about doing BIML script in combination with our BIML code. So when I double click here on table 1, we'll see that I have a definition that's already been created here. And I'm going to go ahead and get rid of these keys and indexes because they're not necessary to motivate this example. And I am going to do our first very simple BIML script. So here I put in a code nugget that just says I'm about to write some code. And I'm going to use C#. You could also use VB if you are more comfortable with that. And I'm going to say for int I equals 0, I is less than, let's say, 10, I++. And this is a very simple artificial loop. This isn't the sort of thing that you would do in practice, but it helps give a nice, gentle introduction to what's possible with BIML. So I'm going to put these windows side by side again. And as soon as I allow this live script to compile, we'll see what happens. It goes ahead and generates 10 columns, all named table column 1. And you'll notice, by the way, another feature of MIST, which is that we have live errors. So we get an error here for each of these, and if I check my error window, it tells me that I've got names repeated within scope, which is not permitted. So I need to make these names unique. The way I can do that is by adding in a new code nugget, which will evaluate to a string. So anything I put in here will evaluate to a string and be put inside of this name here. So I'm going to go ahead and put I in there. So it's going to say take whatever the current value of I is and tack that onto the end of table column. And when I click on OK to recompile, there we go. My errors are gone, and I now have table column 0 through 9. So that's great. But I'm not limited just to making these sorts of small changes within a table or within other root objects. I also have the ability to do things like this. I can say for int j now is, j is less than 5, j++. And now I'm going to close this loop off here. And to avoid the same issue we had earlier, I'm just going to jump in and add table j. So now, as soon as I allow this to recompile, we'll see that we now have 5 tables, tables 0 through 4. And in fact, I'm not limited just to saying I is less than 10. I can say j times 10. So now each of those tables is going to have a different number of columns. Table 0 will have no columns, because 0 times 10. Table 1 will have 10 columns. Table 2 will have 20 columns, etc. And if I wanted to change the number of tables that I had, no problem. I'm going to go ahead and change this to be 9. And there we go, just that quickly. Now I have 9 tables. So you can see that you can make these sort of scripting changes and very rapidly start to produce things that might be interesting to us. But as we discussed earlier, this isn't terribly interesting in practice. It's not, the sort of thing that actually produces a table that would be useful for very much. So let's go ahead and switch to looking at an example that is useful. I'm going to go back to the project view, and I'm going to switch over to tables here, and I'm just going to exclude this file because we don't need it anymore. So once I exclude the file, we see our tables have disappeared. I'm going to switch to taking a look at a file that we've already looked at. So here we have stagingpackages.biml. Now what this does in 34 lines of code is it builds for us a very simple staging a very simple staging load package pattern for us across all of the tables that we have in our solution. Now, as I mentioned earlier, we can get metadata from anywhere. I can go directly, instead of going across the tables in our project, I could actually go directly to a data source and just iterate over the tables that are in a live data source. But in our case, I actually want to build this off of the model that we have in our project so I can do more explicit metadata management. So here's what we're doing. Essentially, we start with our package, and this is something that we originally designed using the Visual Designer to get the package framework, and then we just went ahead and injected the little bits of C# or VB code that we need. It's not the sort of thing where you need a ton of VB or C# expertise in order to get going. A little bit goes a very long way, as we're seeing here. You're seeing maybe about 10 code nuggets here that's doing all the automation work. So what are we doing? Well, for each table in root node, which is our project root, that corresponds to staging.mist up here, for each of the tables in our project, I'm going to create a package called extract table.name, and I'm going to set some options on that package, and then I'm going to create a data flow inside, which basically just does a source to target copy from our source connection to our target connection, and it's using the schema qualified name for our source, and we know this is select star. We don't like that. We'll fix it later. And we have our destination, which is just putting it into our staging destination. And then at the end of this, we actually have a driver package that goes ahead and runs all of those packages that we just created earlier. So that's a nice setup that we have. But the issue is we don't have any tables to actually run this against. So in order to do that, I'm going to go over to import, and this is another feature of Mist. We can import existing table schemas and bring in the BIML for those. We can also import packages, no problem there. If you have existing packages that you'd like to get the BIML for, you can just bring them directly in. So I'm going to click on import tables so we can get some tables, and I'm going to look at source, which for us is AdventureWorks DW, and I want to actually create my staging environment here. So I'm going to click on stage because that's where the database definition is going to go. Now, here's AdventureWorks DW. I'm going to select everything, though I could pick and choose. And I can do things like say, do I want to import foreign keys or not? Do I want to import views as tables or as flattened out as views or as flattened out tables? I have a bunch of options here, but I'm just going to leave the defaults for now. And then I'm going to click on OK. And what you're going to see happen are two great things. The first is you're going to see a dialog box pop up with progress on the import. The second thing that you'll see is where it currently says ready in the very lower left-hand corner of the screen. It's going to change to say background parsing stagingpackages.biml, which is the name of this file here. Since this is live, it's going to detect that the tables collection has changed, and it's going to recompile the script for us on the fly, and then you'll see the staging packages for each one of these tables get automatically created. In fact, some of our customers tell us that this little status bar is actually their favorite part of the whole UI, because it tells them when Mist is doing a bunch of work for them that they otherwise would have had to have done manually. So I'm going to click OK, and we'll see that happen. We've got a dialog box. That fast the tables came in. Now it detected the changes, background parsing staging packages.biml, and that fast I've got my 36 tables and my 36 packages plus the driver and the move data that we had before. Now each of these packages, if I go in, I can see extract dim account is customized to have, for example, in here, select star from dim account. Here we have select star from dim currency, etc. But as you might know, select star is actually a advised strongly against by SQL Server professionals. You're actually supposed to have the column list in there for a variety of reasons: management, performance. If you do a web search for Select Star, you'll have a bunch of folks who explain it on probably the first page of results. So what we'd actually like to do is get the column list here. Now, one of the great things about BIML is that we not only provide methods to do the basic things that correspond to these tags, but we also have methods and properties that are helpers for very common tasks that you need to do with SSIS packages or with SSIS cubes or with relational work. So in our case, if I go ahead and do table dot, I get a list of all of the things that I might be able to do, and I want to get a column list instead of having to do star. So I type in column, and I see that we now have an option here called Get Column List. Now when I click on that, we have a bunch of different overloads of this function that let us, for example, filter columns or provide table aliases or customize the delimiters or do a variety of things. In our case, we really just want to have the plain vanilla list of comma-separated columns. So I'm going to do select table get column list from schema qualified name. And when I do that, all I have to do is save, and just that fast, as quickly as I can get back over, it's now customized. So I have my select currency key, currency alternate key, currency name from dim currency, and if I go back to dim account, we'll see that this one's customized, and I can go to dim employee and see that that one's customized. So effectively, we've now just went and edited all 36 of those packages just by making that one targeted change and letting Mist do the automation for us. But let's take it one step further. I might want to customize my logic a little bit more. I might want to go here in the staging packages and say, you know what, I just don't want to do a copy. I also want to do a little bit of data scrubbing. So I can say things like, for each var column in table.columns, I want to create maybe a data conversion called convert column.name, and I'm going to have a list of columns in there, and I need to close this tag out, and then I'm going to have, let's say, a column which has a source column of column name, because I'm going to be doing a data conversion in here. And there's a variety of different cases under which you might want to do data conversions. You know, maybe you're pulling from a source system that has incompatible types with yours or whatever it happens to be. In our case, we want to take all of our keys, all of our key values that are int32 and change them to int64, because we're going to be using 64-bit keys in this new system. So I'm going to go ahead here and do columns, and now I have some options. I could put a conditional statement inside with another block, but if you're familiar with LINQ, and if you're not, it takes a little bit to learn, probably a few hours to get the basics. This now is extremely powerful in the context of BIML. So I can say I don't want all columns. I just want the columns where the data type is equal to system.data.dbtype .int32. I just want those int32 columns, and I want the columns where the name ends with key. And just that fast, now if I allow this to rebuild, when I switch back to extract dim account, there we go. Convert account key, convert parent account key, convert account code alternate key. And if I show this to my architect or I review it with my team and they say, hey, this is great, but you know what, you really probably shouldn't be putting all of those data conversions in separate data conversions. You can put those all in one data conversion. That's extremely easy to do. All I need to do in order to make that happen is this. I move my for each loop to inside the columns. And then I also I only want a data conversion if I have any of these. If I have more than one, it's fine, but I need to have at least one. So I can just say columns any, like that. And now this will say if I have any columns that end with key and have an int32, then go ahead and create a data conversion called convert keys, and then inside do all the column work. And just that quickly, I've now completely refactored all 36 packages, where now it says convert keys, and inside I'll see the list of keys, instead of the opposite that I had before, where it was a separate data conversion for every single one. And in point of fact, and here we'll see one that had a lot of keys. If I go into something that had no keys, there we go. There's nothing there. So you can start to see how we get a lot of control over our code emission. And I'll show one more example, because some of you might be thinking, okay, I see the power of being able to do automation of patterns. However, sometimes you just hit something where a pattern won't work. Like, for example, the source query. Here you're using a source query that you're automatically creating based on the column list of the table. But sometimes I don't want all the columns, or sometimes I need to apply a filter. What then? Well, that's where additional metadata comes in. You can apply additional metadata in your source through extended properties or through a companion spreadsheet that comes in with a data dictionary. Some people have generated BIML solutions directly off of their Kimball worksheets, for example. In our case, I'll just show you a quick example of one way you can use metadata. I'm going to go ahead and open up dim account, which we brought in, and say, you know what, dim account needs to have a custom source query. So here's how we would do that. I add an annotation. Now this is specifically a BIML annotation that allows us to add metadata to any object anywhere in the system. We use annotations for description, which show up in the documentation that I'll show you later, or we can have things like tags. So I can specify a tag of source query, and I could call this anything I want to, and then just to make this conspicuous, I'll just do select one as foo, right? So there's no question that this is a special query that's not being auto-generated. Now, once I do that, I just need to go back to my script and add a bit more logic. Basically, I say, if table.getTag, we have a helper function for that too. And you might have noticed some of the other things flashing up there. We have get SQL on the table, so you can actually get the create SQL statements. We've got a lot of helper functions in here that are very useful. But here I just want to get the tag. If the get tag is equal to empty string, then what I want to do is exactly what I just did before. This means there isn't a source query tag. So I just want to default to doing what I did before. However, if there is one of those tags, what I'd like to do is use the value of that tag as my select. Right? So here I'm going to use this. I'm just using a bit of copy and paste to speed up the works. And there we go. So if I don't have a source query, I continue doing exactly what I did before. But if I do have a source query tag, I'm going to use that as my query. And just that fast, I let it recompile, switch back over to dim account, and there we go. Select one as foo, but we'll notice that, for example, dim customer is left unaffected. So no matter what you need to do with a framework, you always have the ability to build yourself escape hatches if you need to, and escape hatches that are lightweight, where you don't have to throw away the whole framework just to handle an exception or two. And that makes the scripting capabilities extraordinarily powerful. Before we move on to the next type of scripting, I just do want to point out a couple of the other things that we have here. We focused a lot on SSIS. We also have cube support. So you'll see cube support here, where I can do all my multidimensional modeling. Here's my cube measure groups. I can have my role-playing dimensions with my cubes. Basically, whatever you need to do with multidimensional modeling, we have support for it. We have support for authoring actions, KPIs, perspectives, aggregation designs, partitions, calculations. The only thing that we don't have right now on the multidimensional side is data mining, and that's not something that's currently on our product roadmap. However, by the end of 2013, we are planning to add tabular support to all of this, so that's something to look forward to. Tabular support is coming very soon. We also have principles management, so in one location you can actually manage your permissions not only across the relational side, but also across the multidimensional side, and we emit everything that you need in order to get that to work. Okay, so now that we've had an overview of what you can do with Mist and some of our live scripting features, let's take a look at the next very powerful feature, which is what's called transformers. So everything that we've seen so far has been about creating new assets from scratch, building a whole bunch of packages or a whole bunch of tables based on a pattern that we specified. But sometimes what you really want to do is modify existing objects, and that's what transformers do. So I'm going to switch over to Transformer Framework Demo, and we'll see what I'm talking about. So here's an interesting scenario that I'm sure we've all run into in one form or another in the past. Essentially here what we have is in ETL, and you were just seeing compact display. We actually offer a compact display mode on our package editor as well, so you can fit more in when you have large packages. So what we have here is a data flow task, which is similar to what you might expect to see if you were doing a data mart. We're loading from some source system, we're doing a lookup to get a surrogate key against our customer dimension, and then we're loading into a fact table. And in practice, you would have a bunch more lookups, and you would have some data scrubbing and some other things going on there, some additional application of business logic. But this motivates our example pretty well. So I have this customer lookup. And this is looking up customers against dim customer, and those are currently being mastered off of the same sales system that we're using for the rest of our source data. And then the business comes to us and tells us that they've got great news. They've just bought a new customer relationship management system, a new CRM, and that CRM is going to be the new master for dim customer. So all you should have to do is go in and change the ETL for dim customer, and everything's great. Unfortunately, what they don't realize is that the ETL for dim customer is going to run at a different time now than the ETL for our sales system. So as a result of that, we might be getting sales records in for customers that haven't yet been mastered in dim customer. So I'll look up the surrogate key for those, and I'll find that they don't exist. So there are a variety of solutions to this problem. Probably the simplest one to handle in practice is what's called an inferred member pattern or a late arriving pattern. And essentially what this does is it says, if I can't find a customer that matches my unique set of columns that I have here, what I'm going to do is insert a placeholder row, get the surrogate key out, and keep going. And that way I can finish this ETL without any interruption. And then later on, the ETL for dim customer that's coming from the CRM will fill in the blanks. It'll fill in those missing fields that I didn't have when I was doing my surrogate key lookup. So the simplest way to do that in SSIS, it's not a particularly great pattern, but the simplest possible way to do it is you take this lookup, and on the no match path, you would create a derived columns component that would create a placeholder for your surrogate key. And then I would have an OLADB command component that would call a stored proc or something else on the server to create the placeholder row. And then I would have a union all that brought that no match workflow together with the match path and then kept going. So replacing this one component with 4 components. Now, if I were to do that even just once, it would be a pain. It would probably take 10, 15 minutes to do it just once, and that's if I was going really quickly, and there's a good chance I'd make a mistake. If I had to do it hundreds of times, it essentially becomes cost prohibitive. So we're going to look at a better way. You may have noticed in our BIML script library that we have some files here, and one of them is called latearrivingdimension.biml. So I'm going to open that up, and we'll see that in 26 lines of code, we have implemented that exact pattern that I just mentioned. All right, so the difference between this and the other BIML files that you've seen so far is that it doesn't start with a BIML root node. Instead, it starts with a target directive. Now, we have directives that can do all sorts of interesting things. They enable us to reference other assemblies if I want to call code in some assembly that's already written or something in the .NET framework or something that I purchased. They allow you to define dependencies, to import namespaces, to include other BIML files, to specify properties that have to be supplied to the BIML file before it can run. A bunch of neat stuff that you can do. But one of the very powerful things is what we're looking at here, which is specifying a target. So here I can say, I want this script to target anything of type lookup. And you can target any type in the entire system. This is a lookup component. And when I find that lookup, I have to say what I'm going to do with it. So we have a bunch of different merge modes. We'll look at those in a little more detail later. But for now, local replace is the one that we're going to use. And essentially what that means is I want to tear out my target node that I found, and I want to replace it with what you're going to find below. Now the first thing I do is I check my target node, and remember the get tag that we did earlier? This is another way of effectively getting at the same thing. I want to check to see if it has any annotations with a tag of late arriving. And if it does, then I want to do the replacement. If I don't do anything. It'll produce an empty file and the lookup won't be modified. And I'm not limited to replacing a lookup with just one item. I can actually replace it with a whole sequence of items. So I can put a transformations tag in here and give it a collection of different things to replace it with. So what am I replacing it with? Well, we actually like that lookup. So I'm going to call targetNode.getBiml. This essentially just spits out the code for that target node for the lookup. Target node corresponds directly to whatever we're currently targeting. And then, just like I described before, on the no match path for that target node, we're going to have a derived columns, and then that's going to hook up to an OLADB command that we've already pre-created on the server, and then we're going to have a union all that's going to bring the match path together with that no match workflow. So this 26 lines of code does exactly the same thing that we just said earlier we were going to do. So I'm going to switch back over to loadfact sales, and I'm going to duplicate it just so we can take a look at what this change looks like without changing our initial package. So when I go here and I right-click on this lookup component, we'll see there is an option called Execute Transformers. Now, it's not present on OLADB destination because we don't have any transformers for OLADB destination, but we do have them for lookup, and that's the reason why this lights up. And here is late arriving dimension, .biml, the code that we just looked at. Now, don't blink when I click this, because this is perhaps really the most impressive feature in the entire product stack. Just by applying this transformer, it's going to tear out this lookup, put in those 4 components that we just discussed, and rewire everything up for us. So watch. There we go. It just applied that pattern. So all 4 of these boxes correspond to what used to be just that one lookup. So that's extraordinarily powerful capability. In fact, if I want to apply this across my whole project, I can right-click on late arriving dimension.biml and click Execute Biml script, and I get a list of all of the lookups, and I can pick and choose which ones I want to apply it to. So that's extraordinarily powerful. But as powerful as that is, it's still not really the transformation I wanted. I mean, don't get me wrong, I'm really happy that I didn't need to manually make those changes, and I am even happier that if I've got 100 of these lookups that I don't have to manually change all of those as well. But when it comes down to it, these 4 components are really just plumbing, right? When I think about this problem from a subject matter expert or a BI developer's perspective, I think about these 3 components. I'm doing an extract, I'm doing a lookup, and I'm doing a load. The fact that this lookup happens to be late arriving and has a 4-component pattern doesn't really apply to the business logic any more complexity than me saying, hey, this is a late arriving lookup, not just a lookup. That plumbing is not only something that I don't want to see on a day-to-day basis, but I also don't want to maintain it on a day-to-day basis. If we need to make changes to that pattern, I don't want to have to go and change it in 100 places after I've already applied it. So that's where we start to get into the realm of what we call frameworks. Essentially, what I'd like to do is keep looking at this and working at this logical level, essentially like doing a logical package, but I'd like my physical package with all the plumbing to be automatically created for me when I do a build. So let's see how that would work in practice. In order to see that work, the first thing that we're going to do, we'll delete the one that we've manually expanded. The first thing that we're going to do is a simple build. So I'm going to right-click and say Build and Open in Bids. This is a feature that we have where you can click on any item and build it and take a look at it in bids after it builds. And we have to wait for a second for bids to spawn up. And here I have Load Fact Sales. So when I look at Load Fact Sales, it's got exactly what I would expect in here. It has an extract data source, a lookup, and a load in the fact sales. Okay. Now, if I switch back to Mist, I can now go into my project settings and notice a couple of things. The first thing we'll notice is that, by the way, I could be changing the version to this. If I want to emit this for SQL Server 2012 instead, or with project deployment, I just change a couple of options and rebuild, and it's done for me. We're going to stick with 2008 R2 just for the moment. Now, under command line options, I have this thing called transformation script settings where I point at this framework.biml file. Now, if I open that framework.biml file, we'll see it's a special type of BIML file which starts, instead of with BIML, with a framework settings node. And it allows us to actually just specify the location of a bunch of different transformer BIML files. In this case, we have like late arriving dimension.biml, and we have some other ones down here that we'll talk about in a moment. Key thing is that these are commented out right now, and that's why when we did our build, we got exactly what we were looking at in Mist. But if I uncomment late arriving dimension.biml, remember that's that same transformer we were looking at before, I can still have my exact same 3-component load fact sales, but when I now do my rebuild and switch back, we'll see that a change has been made outside. That was Mist doing the build. I discard, open this up, and now even though we see on the left that we're still using our 3 components in terms of the package we build, we actually spit out our physical package that's ready to go with this 4-component pattern. So this is great. Now we can actually do the work at the level we want to, but we can still have what's required for semantics to be emitted by the compiler and the tools for us. But I still have an issue, because when we actually start running this on larger data sets, we're going to find out that this pattern's pretty terrible. Not only do we have the OLADB command that's running for every single row, potentially, depending on what my pattern of new customers looks like, but we also have batching issues. For example, if I have a new customer come in on one batch and then in the same batch have additional references to that customer, I have to have a smart enough stored procedure to be able to handle that. Now, I'd like to improve this pattern as the architect. So the great thing is my business intelligence developers can continue working. They're on block. They have something that's semantically correct, at least for the purposes of dev testing. And now I can keep working on making this pattern better while they're continuing to move forward and make progress. So I go ahead and implement advanced late arriving dimension. It includes a script project, which is authored using the tools that you saw earlier in the script project editor. And it's, in addition to the script project, about 41 lines of BIML code, which uses that script component. It has a multicast so that all of our loads are actually happening in the OLADB destination. The script component participates in the surrogate key generation and also in caching of that. And we have some other stuff going on here. The particulars of the pattern actually aren't all that important. The important part is that you have the flexibility to change the pattern in any way you want to. So now I can go back to framework.biml and I can comment out the simple pattern that we were using before, and I can uncomment the advanced pattern, which basically just does this. We're using long paths for this one, but it's the same idea. Advanced late arriving dimension.biml and the script project.biml. So now, switching back to fact sales, still nothing has changed there, but when I do a build and switch back over, we'll see that this pattern is now going to be replaced with our new pattern. And if we open up load fact sales and open up our ETL, we'll now see that we have this very complicated pattern, which even includes a script project, all implemented. Essentially, everything that we're looking at in here corresponds to what used to be this one lookup. So we have a tremendous amount of power to start customizing the patterns and practices that we want to use. In fact, we've heard from some folks that they have a practice of having multiple different frameworks. They'll have one framework that they use for their debugging and development environment that puts in a whole bunch of row counts and tracks a bunch of information that generally isn't required in production, and they can use that to debug and troubleshoot issues. But when they switch to production, they use a lighter weight production framework, and the only thing that they need to do off of the same business logic is change some options in which transformer framework they're using, and the compiler does the rest of the work for them. Just to see another example of this in action, we're going to go ahead and implement a very quick logging framework on the fly so that you can see what the code looks like instead of just a walkthrough. It's often useful to see the code being written live. So I'm going to switch over to our BIML editor, and we want to create a transformer. So I'm going to create a target directive, and I'm going to have a type, and in this case I am going to be targeting a package. And I want my merge mode. Here we see a bunch of different options. We've already seen local replace. Root add allows you to do things like creating a brand new package for each table you encounter. Essentially, it's creating an entirely different type of asset that will be added to the root tree. In our case, we want to use local merge, which is a very powerful type of merge mode. What local merge allows us to say is, you know what, for packages, I'm actually really happy with most of what's in the package. I don't want to change the name. I don't want to change the constraint mode or the isolation level or any of that stuff. Whatever you specified in your package is fine. All I want to do is make some targeted changes. And in our case, since we are creating a logging framework, we want to add in a variable. And the variable's name is going to be, let's say, execution run ID. Because we're doing this in 2008, we don't have some of that defined for us by SSIS. And I want to have a data type of, let's say, int32. And I want my default value to be -1. And that's actually an interesting point. I mentioned execution run ID since there's some support for that in SSIS 2012. You also have the ability to have different frameworks based on what your target version is. So you could have one target version that did more logging in 2008 in order to make up for some of the things that are now built into the platform in 2012. We're also going to want an event handler. So here I'm going to have some events, and I'm going to call this one log error event handler. And I am going to have this target the event type of onError, and it has the constraint mode of parallel. And inside, I'm going to have a collection of tasks. In our case, I'm going to do an execute SQL, and its name is going to be log error. Its connection, notice we get IntelliSense on all of this as well, is data warehouse. And then I am just going to use this to call a stored procedure that we have to log errors. Now at this point I could put in parameters and map everything up, but this is a pretty good example just for us to go ahead and see how this works in practice. So now that I have my logging.biml file, I'm going to jump back into framework.biml, and I'm going to put in, let me switch over to this view, I'm going to put in a reference to this, and I'm going to have this be logging.biml, which is the name of our file, and we don't need this bit at the end for this particular file. And now I am going to save this and do a rebuild. Now once we've done that, we have everything that we need in order to inject our logging framework. And when I switch back over here, we see our external changes, and we still have everything in our, we still have this complex lookup pattern, but now we additionally have our log error event handler, and we also have our execution run ID variable. So you can see how very quickly you can start injecting code into your packages, whether it's tearing out and replacing with new patterns, or just injecting logging or auditing or testing or whatever types of frameworks you might want to have. This becomes a very powerful way to encode your patterns in a reusable fashion. You can also interact directly with our error invalidation stack so that you can enforce best practices. And if your best practices aren't followed, you can either correct them on the fly, if that's possible, or you can introduce errors so that the build fails and your developers aren't checking in best practice or non-best practices compliant code. So that's a very powerful set of features. And we found that folks who actually use transformers and transformer frameworks to their full capacity completely transform the way they do their day-to-day development tasks. They work on the logical level and allow the compiler to handle the plumbing for them. A couple of other quick things I want to be sure to show. The first is that we also have the ability to do documentation generation. So here we have a fairly simple solution, but I can go ahead and hit generate documentation, and it creates for me the documentation for the solution. And if I bring over our output directory, we'll see that we've just created here our documentation folder. And I'll go ahead and open this up. I'm going to use Chrome for this because it does better with handling local HTML files than some of the other browsers. And here we have all of the assets in Transformer Framework demo.mist. And I can, for example, click into the packages, and here's LoadFact Sales, and here's a picture of LoadFact Sales. And we have configuration where you can turn on or off the documentation of every single bit of your entire stack. And you'll notice that we don't actually have any summary information here. We haven't actually put any documentation in. So I'm going to switch back over to Mist, and here we have LoadFact Sales, and here we can get into annotations again. So here I'm going to put in description annotation and say, this is my favorite Data Mart load package. And now when I do a documentation regen and refresh, we'll see that shows up. So you can actually do your documentation directly in line. And in point of fact, if you wanted to have a best practice that everything has to be documented, you can write a transformer to say, if I find any packages that aren't documented, don't permit the build to happen. And those are all things that you can very easily construct with your BIML and MIST solutions. You're probably not a huge fan of using this particular style within your organization. No problem there. If you switch back over to your project settings, you'll see the ability to specify a documentation template path. And essentially you just have to give us any HTML file as long as it has divs with IDs for our table of contents and our main content area. And then other than that, you can do whatever you want to. Customize your own CSS, put your own Chrome in there. You can even host this inside SharePoint. We have a bunch of different options for how to host your documentation to greatest effect in your organization. One other quick thing I want to cover is build automation, because we talked a lot about automation workflows and team management up front in the conceptual slides. All of our builds, if you might have noticed, are actually running MS Build. So here we see we're using Microsoft Build Engine. Now we do provide a command line compiler that's very easily scriptable and put in as part of automation workflows, but we also have full MS Build support. In fact, if you go and look at our build files that we use natively, they are BIML proj files. We have visual editors for those that, if you're familiar with MS Build, you probably are familiar with that wildcard syntax. It has a lot of the options that you would expect to find in an MS Build file, but if you can't do what you need to through our visual editor, you can switch over to our .biml proj code editor, and you'll see that this is actually just an MS Build file with a BIML proj extension. And in fact, you can even get an IntelliSense on the MS Build and write your own stuff. So if you're familiar with the MS Build platform, you know that it's extremely flexible, very well supported by the community. At Verigence, we decided not to try and roll our own build and automation system around this product when MS Build was already doing such a great job of that. So you can create your own MS Build files here, and you can use those within your Mist automation, or you can use Mist to generate your MS Build files and plug them into whatever build automation system you already have, whether that's Team Foundation Server or Team City or any one of a number of other continuous integration systems that are out there, so that you could actually do a full-blown nightly build of your data warehouse, and you can even automate the PowerShell in order to make that happen. In point of fact, if everything you've seen here is still intimidating and you're not sure if you could write BIML code, one of the greatest resources that's available is bimlscript.com. Bimlscript.com is a site where the community can share BIMLscript code snippets, walkthroughs, videos, and other assets with the rest of the community. And this is something Verigence participates in, but we also have a wide variety of other folks throughout the community who are adding samples here on a regular basis. We have a Get Started, where you can learn more about BIML. We have the ability to browse through a bunch of different snippets and walkthroughs, and you can search for what you're looking for. And normally, if you search for a particular problem you're trying to solve, you'll find something that gets you at least 80% of the way there. And then you can just start tweaking from there until it's exactly what you need, using that same rapid iterative design approach that we saw just earlier. So there's a lot of surface area to cover in Mist. We covered actually just a little bit of it. It's very powerful. Essentially anything that you might think of that you might want to do to automate or frameworkize Microsoft SQL Server, BI, or data warehousing, you're going to be able to do with Mist, either with the features that you've already seen or some of those features that we didn't have time to get to today. Of course, every organization has its own unique needs, and it's possible that you might have some additional questions for us or need a deeper dive into certain areas of our project functionality. So if you have any of those questions or you'd like a demo customized to your organization, please don't hesitate to contact us at sales@verigence.com, and we'll be happy to set that up for you right away.